Hey, what's up guys? My name is Saurav and this is my YouTube channel Data Science Novice. So if you are new to my YouTube channel, please do like and subscribe. Your efforts are massively appreciated. So in the last video, we built our CNNs and we encountered a problem of overfitting. If you haven't watched that video, I have provided the link in the description. Go ahead and watch it. So now in this video, we will be first visualizing that how overfitting looks like, and then we will see how to deal with the problem of overfitting. So let's get started. So first we are going to plot the losses, that how much was the loss at each epoch. So to do that, we call model.history.history, and this returns a dictionary. So let me show you. So here we see the history of our models, like what is the loss, validation loss, training loss, and all that. So now to convert this dictionary to our pandas data frame, we just have to call pd.dataframe. So now we are going to save this data frame into a variable called loss. So let's run this cell. So now let's look into the data frame. So here we see that we have losses, that is training loss. Then we have accuracy, that is accuracy of training dataset. And then there is validation loss and validation accuracy. So let's plot the graph to see how the overfitting looks like. So we are going to call plot method and then passing our training loss variable and then labeling it with the training loss. Along with that, we are going to plot our validation loss. Okay, so let's check the validation loss. Okay, and then we are going to label it with the validation loss as well. And then calling legends to get those labels. Okay, so we are getting an error. Okay, so it's valid loss, not losses. So let's run this cell again. So here we see that blue line representing the training loss and orange line representing the validation loss. So initially during the training, validation and training losses kept on decreasing, but after certain epochs like 7 or 6, the validation loss kept on increasing, but the training loss kept on decreasing. So what does it tell us? It is telling us that while model is doing very well on training data, it's not performing good on test data or unseen data. And this condition in machine learning is known as overfitting. So our model is overfitting. So now we have to deal with this problem. So to tackle this problem, we use two things. First is dropout layer and then early stopping. So in dropout layer, what we do, we just drop some neurons deliberately at each epoch, and this is done randomly. So suppose you have 100 neurons in a layer and you set dropout equals to 10%, then the network will randomly choose 10 neurons from those 100 neurons and will not fire them. So in this way, you are able to generalize the model well. So next we are going to talk about early stopping. So the idea behind early stopping is, as soon as the difference between training loss and the validation loss start to increase, we stop the training. Okay, now we are going to implement dropout and early stopping in our project in order to make our model more accurate. So let's do that. So first we are going to copy all the code we wrote earlier. So let's do that. Now we just have to add dropout and pass argument 0.5. That means 50% of the neurons will be off during the training. So you can choose any value between 0 to 1. So next we are going to import early stopping. For that we are going to call tensorflow.char.callbacks and importing early stopping. Okay, so let's run this cell. Okay, so we are getting an error. So I have to make it capital S instead of small s. So let's do that. So let me configure the early stopping, then I will explain you what's happening there. So let me do that. Till then, if you haven't subscribed to my YouTube channel, please do like and subscribe. So first we are instantiating the early stopping. Then monitor is equals to valid loss, that is keep eye on validation loss, and the mode is equals to minimum, that is keep the eye on validation loss when it's minimum. and setting verbose equals to 1, that is nothing, just to show output. So next we have patience, that is once it reaches the minimum loss, how many more epochs you want to run. If you set equals to 0, the training will stop as soon as the validation losses reaches minimum. Here I have set equals to 5, it will run for more 5 epochs even after getting a minimum loss. Okay, let's run this cell. Okay, so I'm getting an error, so let me correct it. Let's fit the model, and to do that we just are going to copy paste the same code. This time we are going to pass an additional argument, that is callback, and putting early stopping there. Let's run this cell. So the model has started the training. So now we are going to fast forward in time, and then we will see that how the model was able to tackle this problem of overfitting using early callbacks and dropout. So our model has trained now, and it is stopped at epoch 9 because it first detected the minimum validation loss at 5, and I set the patience equals to 5. So that's why it ran for 5 more epochs. So that's why it stopped at 9th epoch. So let's visualize the loss history for this model, but this time we are going to plot it along with the previous model. So let's copy the above visualization code. So before that we have to save the loss for this model, and we will call the loss for this model is loss1, and using the same data frame function. So now let's check the loss for this model. So let's copy paste the visualization code twice, one for the previous model and one for this model. Now let's make some changes. So once done, press shift enter. So let me configure it for you so that you can have better understanding about it. So here the extended lines are from previous model and the short lines are from the model we created using early stopping and dropout. That's all for this video. In the next video, we are going to make prediction on the test data. So if you like my video, please do like and subscribe and press the bell icon. Till then, bye, stay safe.